This is our Fireside Chats with the Pittsburgh Technology Council, and I'm Jonathan Kersting, and I get to have the best conversations with our members about the things they're innovating. They're building solutions. They're building just everything you can imagine to make the world a better place. And today I couldn't be more excited for our Fireside Chats. As our fires are crackling here, we have George Skoptsov with me today. George, it's so much fun having you here. I've interviewed you quite a few times over the years. It's been amazing watching your journey, and I'm so excited to talk to you today because we have a little bit of an announcement to make about some news that you've been making, and talk about just really how the company has progressed over the past year or so since I've last talked to you. I know you're up to some great things. I'm excited to talk to you today.
Yeah, super excited to be here. Thank you for having me, Jonathan.
It's good stuff. It's good stuff. George, tell us about HQuest, and really you've evolved a lot over the years. Tell me what's going on with HQuest.
Yeah, absolutely. Well, as you know, we're not a one-trick pony, right? So carbon black is something that we're commercializing, but we started the company more than a decade ago with a very humble goal of reinventing the way we use natural gas, helping it realize its full potential.
Exactly. Especially when I think about how much natural gas we have right here in Western Pennsylvania.
What's funny, right, is, we ship it off all over the world now to be burned, right? Or we burn it right here, for its energy value. And if you had something valuable, would you burn it? No. If you're going to burn it, it has to be inexpensive.
Exactly.
Right? So we see the potential, or we saw the potential, and we have realized it, to take this natural gas and instead of using it as a cheap fuel, right, using it as a feedstock as a much more valuable feedstock for materials. Advanced carbon materials like carbon nanotubes and graphene and battery-grade graphite, but also carbon black.
Yeah. And these are the things that are these are what drive modern civilization as we know it today, these materials that you're talking about.
Well, beyond that, I mean, chemicals like ethylene, right? And all of that stuff can come with a stream of CO2-free hydrogen. And because it's a byproduct, you can sell it at the price that nobody else can match, right? And that was the vision.
It's been a decade. Man, you're tenacious.
Yes,
10 years of chasing this down is pretty cool.
A decade later, a lot of gray hairs later, a few $1 million of research and development money from Department of Energy and NSF and our patient investors. Yeah, we're here. We're commercializing our technology. Our focus right now is across all of these materials, right?
Okay.
And it's no longer a potential. We have actually proven the pathway from that methane molecule to every single one of those materials that we mentioned.
Yeah.
But our focus is on carbon black.
We got some here.
Right.
Black. This is the compressed.
Correct.
Yes.
So you can.
It's a nice. I believe that if you open it up, it has a very
just don't.
very aromatic. Yeah.
You can't smell it. There's no smell to it. There are no chemicals.
We use carbon to get smells out of things, right?
Exactly right. You can get the tastes and odors out of stuff, out of water, out of gases, using this material, but it's not something that people usually use carbon black for. But this is something that we are looking at. But don't open this one because this is the powder, and this
gets everywhere. You breathe it. No good.
It's like opening a toner bag, right? And it's actually exactly that because people do use it for toners.
Really?
The funny thing about carbon black is that everybody touches it, multiple times, on a regular basis, comes into contact with it, but no one has ever heard of it, right, or knows what it is. And it's $20 billion market, right?
$20 billion market.
That's right.
That's pretty big.
But it is growing, and it goes into 40 industry verticals, and we mentioned toner, right? But the two primary sectors, and especially the ones that we're focused on, has to do with automotive applications. 80% of the carbon black goes into rubber materials.
Like tires and stuff like that.
When you think of a tire, right, you think, okay, it's made of rubber, right? But actually 30% of a tire is made up of carbon black.
We back up 30%.
That's
so
right.
that's infused with
rubber. It's almost a third.
Yeah, a third of the tire is actually, okay.
Yeah, a tire is a composite material.
And how are they traditionally getting that carbon black to make those tires or whatever it is to get carbon black for anything?
Right, so that's where we're getting to the crux of the issue, right? Because carbon black is a strategic material. Very little of it now is made in the United States.
Really?
A lot of it is made overseas. 25% is made in countries like China and Russia.
Okay.
And so it is a strategically sort of vulnerable material.
So
right?
this is an important material that we actually rely on some countries that may not like us so much in order to get that. So the idea that we could produce more of it here locally sounds pretty enticing to me.
Right, except that the way it's made now is not super sustainable, right?
Okay.
It uses
Yeah.
like legacy, unsustainable fossil feedstocks,
Okay.
like coal tar, like heavy oils. It has a pretty heavy CO2 footprint, and that's why it's, what we have done is so important, because we have actually replaced those fossil feedstocks with that. A lot of it actually gets combusted in the process, right? We have replaced it with natural gas, and 100% of that natural gas goes into the material. None of it is turned into CO2. We don't have any combustion in the process.
Wow.
So it's a complete reinvention of that legacy process that has been around. I don't know, some people say 100 years, some people say 5,000 years.
Right, exactly, yeah. No, so to walk me through how this happens, so you have natural gas coming through. Is this where you have your microwave that kind of cracks it and you get some hydrogen and then you get the carbon black that falls out that would have been combusted and that becomes the byproduct that you can then sell?
We talked before, haven't we?
I think we have, and I was very impressed. I'm just making sure I got that all right. Pass the H-Quest test.
But seriously, what we have developed is a very compact and elegant process, one single stage, no catalyst, for making a variety of carbon materials. And carbon black just happens to be kind of the easiest. Ironically, typically it's very difficult to make, which is why we don't make it here, everywhere all the time.
Right.
But for us, carbon black is actually the easiest material to make.
And I think about how important that material is to so many things we do, like tires for our cars and toner for our printers and other advanced materials like nanotubes and things like that.
Right. Well, I think hopefully toner for the printers is not a super quickly growing market, right? Hopefully we're printing less, not using so much paper. We're trying to be digital as much as possible, right?
Once again, the digital fire. I mean,
exactly. This is very sustainable.
It very is, yes.
Yeah. But the fastest growing market for carbon black is in the battery applications.
That makes total sense. You think about everything that's running on a battery these days.
Carbon black is conductive, and as long as it can be, very high purity, it's a key ingredient in lithium-ion batteries, for example. Without carbon black, well, lithium-ion batteries simply wouldn't work.
Right.
But the properties of that carbon black actually determine everything from the capacity of the battery to its ability to sustain rates of charging and discharging without overheating. So super important for the growing EV market. It's growing at 25% per year.
And there's so much talk about being able to sustainably build these batteries. And this is a big piece of that, where if you're able to get this key material.
Exactly right.
That's amazing.
Exactly right. And, they're willing to pay really high prices for that crucial material. It goes up to $20 per pound or higher for the battery-grade carbon blacks.
Wow.
So, in our work, we're focused on, when we say we're focused on carbon black, we're really pursuing two of those sectors, right? One is for the very large applications in the tires, right? But we're also working with Japanese battery-grade materials manufacturer specifically for those high-end battery applications.
So you've made some really interesting news lately. You have a collaboration with Goodyear that I'm just really excited about. When I see a company like yours linking up with a company and a brand like Goodyear, I mean, they don't work with just anybody. So can you tell me a little bit about what you're doing with Goodyear?
Yeah, absolutely. What do we think about when we hear the word Goodyear? Well, tires and the blimps, right? But our focus is on the tires.
Okay.
Goodyear makes a lot of tires.
They do.
And so they have to buy a lot of carbon black.
Yeah, I can only imagine the shipments of carbon black coming into Goodyear to pump out all those tires.
From all over the world, right? And ironically, not so much from the United States. So what we're really helping Goodyear is secure their supply chains, right? Because this is an uncertain world.
Very uncertain.
Right.
And earlier before you were mentioning how, carbon black comes from different parts of the world that maybe aren't so friendly to us and they could easily cut those supplies off. Yeah.
Well, with 25% of the carbon black made in, China and Russia, it is right now, the state of the world is such that it is a concern, right? So we're in a good position to secure those supply chains for this, critical material as we have discussed. But on top of that, we can actually make that carbon black more cost competitively,
Okay.
than the stuff that is made from conventional
Exactly.
feedstocks.
That's
like
being
the
shipped
fossil
from all
feedstock.
over the world.
And shipped, exactly, shipped from all over the world with a huge CO2 footprint, right, on the transportation, on the making. We can help reduce all that.
I love that.
So we're helping sustainability goals for the
100%.
automotive industry.
Yes.
On top of that, co-location of our systems.
So your system would actually be on site, able to produce the carbon black there?
That's right. That's one of the potential applications.
Okay. Yeah.
And co-location makes so much sense because they already have a lot of natural gas,
Right.
being utilized there. They have that supply. If they can make carbon black right on the spot, you eliminate all the transportation costs, all the
Saving some money.
transportation risks,
Right.
and you can use the hydrogen that's being made as a co-product to the carbon black for decarbonization of the current operations.
Wow.
All the boilers, all the furnaces.
Everything
They're-
being run through Goodyear, then they could actually get the carbon black they like, and let's just power the facility while we're at it too.
Exactly
See, that's
right.
amazing stuff. First off, I would have to assume Goodyear's got to be very excited that they're linking up with you to work on this to see how they can actually make this a reality.
Well, I don't want to speak for them, but the fact that they have gone into this relationship with us
Says something
and
good. They're not going to mess with this anybody. Simple as that.
exactly, but this relationship is a proof that we actually are making a real material.
100%.
Right? We're not just saying like, oh, we're going to make this new material, we're going to invent new markets for it, we're
Right.
going to make...
You're
invent
solving a
new
problem right
applications.
now. Yeah.
Exactly. But it's very difficult to actually make a material that matches something that has been in the market for so long. Right?
Good stuff. Yeah.
It's been a crucial part of a tire for 100 years, right? And you have to replicate that performance of something that has been perfected
Right.
over 100 years. It's a difficult task, and the fact that we have passed the bench scale tests, we are now moving toward tire tests. That's a huge
sign.
testament
Yeah.
to
It's very exciting.
to what we have been
Very
able to
exciting.
accomplish.
That's why I can't wait to see what happens next year. This time we're going to be talking about even more stuff. So what are your next moves? It's kind of crazy. We are actually moving to 2026. So what are you expecting for the next next year coming up? I can only imagine.
Yeah, I mean, we have, like I said, multiple partnerships, right? I can't, unfortunately, talk about
Okay.
a lot of the detail, but, we're
There's stuff
moving-
cooking, right?
Yeah, well, we've completed several phase ones,
Excellent.
with our partners, right? Great results. Basically, we're moving to phase twos in 2026, so much larger,
Well, I'm
vessels
excited
for
for you.
us. And
Yeah.
this is, non-dilutive, right? Which is great. But most importantly, it is the actual proof that we are making, real stuff, right? Our goal is not to invent this new material and then invent new uses for it and then invent new markets,
Yeah.
right? What we want to do is take something that's abundant and right now is undervalued, right? $3 of
I
worth
was
of
going to ask
natural
you about
gas.
that. Makes $300 worth of like.
$300 worth of materials,
Yeah.
right? If you're targeting something really high end for the battery market.
Right.
Absolutely. I mean, it's a huge value multiplier.
Yeah,
right?
that's what I'm talking about.
But it's not, but it really, we're thinking about it as unlocking the true value that was there all along.
Exactly right. Yeah. And that's transformative, and that's happening from Pittsburgh. I'm glad H-Quest is doing that here, and that's just fantastic. I wish you continued success. I look forward to hearing more announcements about as you move through this whole journey of taking this technology and getting it into the marketplace.
Absolutely.
And doing what you're doing. It's amazing stuff, George.
Yeah, well, Pittsburgh is a very special place. It's here in western Pennsylvania where the natural gas is, but
Exactly.
there is natural gas in other places too. Houston and Alaska, and what's important for us about Pittsburgh, right?
Yeah, tell me.
I mean, we have how many universities do we have? 7, 8, 9?
Quite a few.
You
Yes,
know,
and they're all really good. Yes,
Exactly. So this is where the company is all about the people, right? And the team that we have built, right? They all come from universities in this area, right? They have been attracted to Pittsburgh, right? We have a lot of folks from, all over the country, all over the world, from California and India, but they have been brought here by what
The
we
university's
want to
attractive,
build.
and we want as many people coming to Pittsburgh from around the world to build great stuff like what you're doing, George. And I tell you what, you're bringing the heat, dude, and you're making Pittsburgh proud with the work that you're doing, because this is tough work. And it's been an honor to tell a little bit of your story today. I mean, it has me very excited.
Oh, thank you for.
The fires are crackling. If you want to hang out, I got some marshmallows, and we can maybe, I don't know, add this to the hot chocolate and see what happens. So,
sounds
yeah.
great. No,
Thank you
thanks
so much. No, I
Yeah,
really
no, thank you
appreciate
very
it.
much for having me here. This is our. I lost count how many times we spoke, but I think every time, we're at a new
Just
level.
something new, yeah. And that's the joy of my job, is getting to watch you hit these milestones along the way. It's just so rewarding to watch our members just keep succeeding and building. And when there's
Love
a
it.
set, they learn from it and then leap ahead. And it's not an easy journey, but you're doing it, and it's great stuff. George, you're the best.
Thanks very much, man.
Thank you, sir. All right.